In our last piece of learning, we learned about the factors that affect atomic radius, and we were particularly looking at this idea here, effective nuclear charge. The fact that the more protons in a nucleus, the stronger its nuclear charge will be on the electrons, but also that when you've got multiple energy levels, that these ones at the lower level will shield that charge from having such a big impact on the outermost or valence electrons, and so the effect of that nuclear charge will be reduced. When we look at ionic radius, we're not looking at a periodic trend, we're really just comparing it to whether it's bigger or smaller than the atom that the ion was formed from. And so for this we need to have our electron configuration of the atom and the ion so we can compare and contrast those. Here's a bit of an overview, and it's really well summarised on pages 21 and 22, or summarised on page 21 of your SciPad, and there's some really good questions on pages 21 to 22 in there as well. So, the key thing is what happens when these ions form. Remember that cations are positive, anions are negative. So, cations got the T that looks a bit like a plus, a negative ion, anion. Well, when cations form, they're losing electrons, and that means that they lose the electrons that are furthest away from the nucleus, so the valence electrons disappear. That means that there's an increase in effective nuclear charge on the outermost electrons because they've lost the ones at the highest energy level. So for example, if we think of calcium, which has got electrons in the first energy level, the second, the third, and it's got its two valence electrons in the fourth energy level, it loses those two, so it only has electrons in three energy levels. So the effective nuclear charge on its outermost electrons is higher because there's fewer energy levels. There's 20 protons pulling on each electron, and now that they're only in the third energy level, there's less shielding, so an increase in effective nuclear charge. So cations are smaller for this reason. Anions are a different case. There's no change in the effective nuclear charge because they gain more electrons at an energy level that has already got electrons in it. So oxygen to become oxide, they both have electrons in only two energy levels. and still, there's only 8 protons in each nucleus for oxide and oxygen atoms. So there's only the pull of 8 positives. There's no increase in effective nuclear charge at all on the outermost electrons. But now you do have electric repulsion. There's more electrons in the second energy level, so they're naturally going to repel each other and make that electron cloud a little bit bigger. So we find that anions are always larger than the parent atom because they've got more electric repulsion in the same energy level. One of the key things that students get wrong is that they say, oh, there's less positive charge on each electron. There's not. There's still, for oxygen versus oxide, there's still 8 protons in the nucleus, so each electron feels the same effective nuclear charge on it, so long as they're in the same energy level. The impact, what makes them bigger, is electric repulsion, and that's quite a big effect. So we use these two principles to explain why cations get smaller, that is that they lose an entire energy level, so the effective nuclear charge on the outermost electrons is increased because there's less shielding. Or if an anion is formed, why they're larger, even though the effective nuclear charge is the same on each electron, the electric repulsion within that energy level has increased because there's more electrons in the same energy level.